Hello and welcome to this presentation about the work done on contracting in distributed manufacturing, which was carried out under the mAkE project. I'm Max Warte, the Technical Coordinator of the Internet of Production, and I've led the development of tools and workflows that will be presented in this video. The Internet of Production is a global alliance of people who believe in a future of production defined by decentralized manufacturing and shared knowledge. We are a member of the mAkE consortium and have led the work on the technical innovative infrastructures that have been developed as part of Work Package 4. The objective of Work Package 4 is to increase opportunities for hardware digital innovation hubs to engage in socially driven business and collaborative capacity building by accessing skills, machinery and contracts, which are three types of digital infrastructures that enable distributed manufacturing across the mAkE network. The task in Work Package 4 that's related to contracting is to develop a prototype system that makes it easy for customers to contract with many manufacturers. This aligns with the vision of distributed manufacturing as a way to shorten supply chains through the flow of information and positioning makers and makerspaces as key drivers of innovation and solution providers for local needs, while facilitating access to local markets through local production. Now I'll present the research and development that was carried out over the span of the mAkE project to explore contracting in distributed manufacturing. The initial part of the work on analysing contracting was carried out by Anna Serralo in identifying the different roles involved in distributed manufacturing and how the interactions between entities taking up these roles differ from similar roles in centralised manufacturing. As you can see, these roles are divided into four types: demand side, intermediary, supply side, and independent roles. And I invite you to visit the link shown in this slide to explore this work in more detail. Building on the work of Anna Serralo regarding roles, we found that contracting in distributed manufacturing shares many of the same principles as contracting in other scenarios, especially concerning quality assurance, insurance, logistics, delivery, materials, and other responsibilities. These core issues remain consistent regardless of whether the manufacturing process is centralized or distributed. However, what distinguishes distributed manufacturing from traditional centralized manufacturing is the allocation of roles and responsibilities. In a centralized setting, the manufacturer typically handles a wide range of tasks, shielding the buyer from many of the complexities involved in the process. The contract generally involves a direct relationship between the buyer and a single manufacturer who assumes most of the roles and responsibilities. Distributed manufacturing, on the other hand, is likely to involve multiple entities, each potentially taking on different roles within the manufacturing process. This dispersion of responsibilities means that the buyer might need to engage more directly with aspects of the production process that would otherwise be managed by the manufacturer in a centralized setting. Because of this, the contractual landscape is more complex, leading to multiple variations in how responsibilities are assigned and managed between the participating parties. To manage this complexity, contracting in distributed manufacturing needs to be designed with a high degree of flexibility to allow for different configurations of roles while ensuring clarity, accountability, and cohesion across the entire process. This adaptability is needed so that regardless of how responsibilities are divided, all parties involved can work together to reach the desired outcome. The next phase of our work involved analysing various distributed manufacturing processes so that we can develop a prototype of a system for helping buyers manage distributed manufacturing workflows. To get a better handle on the various workflows, we began mapping out various distributed manufacturing processes to see how the different roles come into play. We looked at a number of different scenarios, with a particular focus on distributed manufacturing processes that involved makers and makerspaces. The goal of creating these process maps was to develop an understanding of the requirements of a system that would assist in automating parts of the contract management and production process especially from the buyer's point of view. After mapping various processes for distributed manufacturing scenarios, the one we decided to implement in the mAkE virtual trials is a process that's largely based on the one used in the Innovative Manufacturing in Africa project that we undertook in 2023. The process involved 4 types of participants. We had multiple makers take the role of manufacturer, while makerspaces took on the role of quality inspector, ensuring that the production met the required standards and specifications. We had multiple healthcare facilities in the role of recipient of the manufactured products, and the initiator or the buyer who took on all of the other roles in the distributed manufacturing process. These earlier trials involved 9 makerspaces in 3 African countries carrying out simultaneous fulfillment of the order. However, none of the order processing and management was automated. One of the challenges with the earlier process was that the buyer had to manage the production run of each of the manufacturers separately. So, for the mAkE trials, we developed a prototype of a system that will allow the buyer to have a single interface to submit their order regardless of how many manufacturers were involved in the process. This system, which can be accessed using the QR code on this slide, provides a front end for the buyer to submit the details of the order. Once the order is submitted, the rest of the workflow of the distributed manufacturing process is carried out by an automation that prompts each participant to carry out their required tasks in the correct sequence to ensure that the order is fulfilled. This prototype was demonstrated in a number of workshops to get feedback from participants about the usefulness of having an automated system for submitting and tracking distributed manufacturing contracts and orders. The workshops explored the dynamics of distributed manufacturing, emphasizing quality assurance, resource management, collaboration, and the evolving role of makerspaces. Participants highlighted the need for clear workflows, shared quality assurance frameworks, and a focus on community-driven innovation balanced with financial sustainability. The discussions also centered on the feasibility of a distributed manufacturing contracting platform addressing concerns about manufacturer capacity, automation, and customer trust. The workshops underscored the importance of balancing logistical and philosophical considerations while integrating user-centered design and fostering collaboration to enhance the scalability and impact of distributed manufacturing systems. We aim to continue this work by building on the findings and feedback from this research and development that we did over the span of the mAkE project. The prototype that we built was based on a specific implementation of the distributed manufacturing scenario from earlier innovative manufacturing in Africa trials. We would like to take this further by testing systems that implement some of the other distributed manufacturing scenarios and processes that we mapped during our research. The feedback that we received on the work that we carried out in trialing the prototype for contracting in distributed manufacturing inspired some other ideas, such as developing a catalogue that would help those who are interested in adopting distributed manufacturing to understand the various contracting processes and scenarios, which could serve as a very useful educational tool. Another idea is to develop an AI tool that can assist various parties to generate contracts in a way that's tailored specifically for distributed manufacturing scenarios. We'd also like to explore the implementation of a system that would allow for flexible configuration of roles and processes in a way that reflects the variability and complexity of different distributed manufacturing models. We also uncovered a need for having a library of standard contractual clauses that could be tailored for various jurisdictions. We'd like to invite you to visit the Internet of Productions community forum so that you can share your ideas on future developments for our work on contracting in distributed manufacturing, and to also read the report on our work under mAkE's Work Package 4. Thank you for watching this video, and we look forward to your feedback and to exploring any ideas that you have for moving this work forward.